Speaker is uh, Vivin Krishnan, software engineer, IBM. Vivin Krishnan received his MTech degree in software engineering from Kochi. He has been working with IBM Software Labs, Bangalore since 2007. Presently leads mobile-first platform product development in ISL. So over to you, Krishnan.
Thank you, everyone. Good
Sir.
afternoon. Thank you for the opportunity. So what I'm presenting here today is a signature-based authentication modality that will be used for adaptive authentication in healthcare applications. And over the next few minutes, we'll go through an introduction of the topic, the background on the keywords, the methodology proposed, analysis done, a formal analysis, will conclude, and then we'll open up for QA. So currently, we know that with increasing penetration of internet, our health sector has undergone quite a digital revolution. There are many body-worn sensors that are used to monitor different biometric signals and generally communicate with the healthcare service, mostly interface through a mobile device. Now, as it is healthcare data of an individual, this becomes very private and is quite confidential as well. So any unauthorized exposure of this data is pretty bad in terms of the user's individual's privacy, as well as it can be used by malicious agents to possibly even create a biometric signature of that individual and use it to access resources that or even tamper with their healthcare data. Now, traditionally, we have always depended on single-factor authentication. So we generally depend on one mode of authentication. Possibly most the common ones are username, password combinations, or PIN, identification numbers, etc. And as time went ahead, it has also evolved into the usage of biometric modes like fingerprint, etc. But these alone are not sufficient because an attacker, let's say on a compromised network, an attacker may be able to sniff out and find out that single factor, the single authentication modality, may be able to break it. So this prompted the need for multiple authentication modalities, which it's not the exact same modality or the same category of modality, not always a password or not always, it's a combination of such schemes provide for better coverage, because it becomes difficult for an attacker to find and crack all the involved modalities. However, this again, while it provides coverage, it also is not sufficient. Over time, it has not proven sufficient. So this is wherein it brought about the need for something called an adaptive authentication. So what are these keywords that we've just discussed? So traditionally we consider three types of authentication. It's knowledge factor, something you know; inherence factor, something you are; and possession factor, something that you have. So knowledge factor is something you know. It could be a password, a username password combination, or a PIN, while something you are, that is maps to your biological signatures, let's say biometrics, fingerprints, iris, retina scan, etc., or the use of something you have, something like smart cards, etc. However, even with these multiple modes, so a multi-factor authentication takes modalities from either of these different types and applies it. But generally, we have seen it's all a static application. That is, first the user is prompted for a username password. Thereafter, the user is asked to enter, let's say, an OTP or place a fingerprint and authenticate the fingerprint. So individually, these are available, but these are still individually susceptible to be broken. So a fingerprint, let's say, can be lifted off a surface. While it's a rare scenario, it is not uncommon either. It can be done. Similarly, the username may be cracked through eavesdropping, like we mentioned earlier. So combined in a static application of MFA, this system can again be broken. Plus, there is also the aspect of usability, where if a user is prompted with multiple challenges, authentication challenges in a sequence, this definitely affects usability and has been a detriment to a wide adoption of strong security rules. people say, okay, if there are multiple authentication attempts, they as well choose not to go with it. So that is also a detriment. This is where the concept and the idea of adaptive authentication comes in. What is it? So adaptive authentication factors in attributes other than just the credentials to decide if this user should be challenged again. So this is done by collecting and creating a behavioral context of the user or the user's behavior. So normally, if the user has a habit of logging in between 9 to 10 every day, and one day the user chooses to log in at midnight, it does not indicate this is not the actual legitimate user or an attacker, but it still represents and has a level of there is a variance in behavior. As such, there can also be a risk associated. So adaptive authentication is the idea of collecting multiple attributes, contextual attributes, create a profile of the user, and then check variance of attributes against against an established baseline profile, and then arriving at a risk score. So based on the risk score, the user can be challenged with a different authentication modality. So depending if the risk is high, a much stronger authentication challenge can be thrown at the user. If not, the user can be allowed in. So this also brings in a lot of the covers the aspect of usability, because the user is challenged if required, if the system deems and finds a risk, not always. So some of other keywords that we'll be using through this proposal is one, JWT, or a JSON Web Token. So this is a standard. It's a standard defined under RFC 7519 of the IETF. So it's a data structure where you represent, so it's a data structure to hold data. Think of it as a container for data. So it's a JSON representation, not essentially always. You can also have it XML representation, but it is a data structure. And something called a JWS, or a JSON Web Signature, defined under RFC 7515. Think of it as a signed JWT in the simplest of terms. So this is the attribute set that we are proposing, and to capture and create a behavioral profile of the user. I'll quickly go through these. So let's say location of the user. If the user is normally, the baseline profile says that user normally logs in from Bangalore, but so a variance from between in 1 hour, if it shows that from Bangalore it has shifted, let's say, to New Delhi. So that definitely is not a normal thing. So it indicates a high level of risk. Or the variance in time, like we mentioned, or if the user, unlike the usual behavior, tries to access resources that they have never, or tries to override their regular roles. So these are all some of the aspects that can be considered to building a context for the user. Similarly, it is also extended towards to the application, the dedicated application user is using. Do not just limit it with the user itself. You may consider the application and the device on which the application runs also as part of the context. So this is a typical representation of the JWT. So there is a JOC header. Here you can indicate it's the JSON object signing and encryption header. So you can indicate the algorithm that was used to sign it. So the RFC says typically it is H256 or RS256 or 384 ECC, EC256, 384, etc. And you can define the type of it. And the payload of this JWT is a set of claims. So there are some keywords, but you're also free to add custom keywords. So some of it can be who this is issued to, the audience, or an expiry time can be specified as a claim. Finally, there's a signature block wherein you calculate a base 64 of both header and payload, and then you sign it. So you use a specific algorithm, RS250, let's assume, to sign it. And this now becomes a signed payload. So this is signed with the private key, so that whenever with the public key available, a server can verify if it is indeed coming from the client, originally intended client. So what is the objective here? So this is to come up with an authentication algorithm that can integrate with an adaptive authentication system, and that it be lightweight, so that it can run on a multitude of devices, but still use a open and standard data structure and not be bound by some custom or proprietary data structure for transport. So for this, we have adopted and extended an existing authentication algorithm by Sumitra Binu. And we have also incorporated the use of signed JWT, which enables the purpose of data integrity and authenticity. So the modifications that were made to the base algorithm: one, we reduce the number of computational cycles or the operational cycles required, and the information that is stored on a mobile device is actually physically stored is minimized. It's mostly restricted to in-memory or minimally computed at runtime on the fly. And the behavioral context is also captured in every request. And finally, a signed JWT will be used for transfer. So these are some of the notations that we are using. So we'll directly jump into the algorithm. So here, the mobile device, there's a registration phase where the user provides their username and password. It can also be combined with biometric option as well. Now, once the username and password is captured, none of this data is ever transmitted to the server or even maintained on the device in plain text. It's always hashed or XORed and hashed. And then you create a key pair, an RSA key pair, a 2048-bit key pair, and you embed this data into the JWT and sign it. So one, you sign it, assign the JWT with RS-256 or HS-256 with a loaded and the key there would be the private key generated from the key pair. This key pair is stored securely in the mobile device. And this is transmitted, the hash of the identifier and a combination of the password and identifier is again hashed up is transmitted. So the server holds these values. So now coming to the use of JWT, first thing is, like I was mentioning, we can add a claim that says the expiry time is so and so, and it is not valid after X amount of time. So immediately it can be rejected if that claim is not met. Secondly, once if it is indeed valid, the server does its computations. A 256-bit salt is used. We have some XORs. We generate a symmetric key here. To send back the data. So this is again not sent as it is. It is computed. A unique identifier and a secret key for this device alone is computed. So it is not a secret key common to all clients. This is specific to this this user, this mobile device, and this application combination. So you encrypt this message with the key calculated here. So you persist in the server only few of this data. One is the secret key calculated, the identifier, the combination of username password, and the public key that can be derived from the JWT, the signed JWS that was received. So this encrypted message and a combination of the XOR value of the identifier and salt is sent back. So this is extracted, XOR back to calculated, and based on this value now, the key is the symmetric key is computed at the client. It decrypts a message and then stores only the identifier securely in the client device itself. So moving on to login, here is where the attribute from now on the attributes come into play. So again, computation is on the username because this is a login phase. So you compute the and ask the user for the username, password, credentials, even biosignature. Here again, you compute the key. You do not store it or there's no handshake. It's computed, embedded into the JWS, and also a timestamp is involved and a nonce. This is to ensure replay attacks are not done, and also the liveliness of the actual payload. Signed with the same private key as earlier. At this point, there will be multiple levels of check. One, server can check if the expiry claim is met. Server can check if the timestamp does not pass on, it does not exceed a delta. If not, this can be rejected. And finally, the public key match. If not, reject. If all these conditions are met, only then you look up the identifier from earlier. It is not transmitted otherwise. Decrypt, Now the attributes are passed in the encrypted payload. So now you decrypt, validate the variance through a specific module that checks for the variance. If there is a variance, you throw in another, you ask that user that, okay, one, either reject depending on the level of variance and risk. If not, throw another challenge here. Otherwise, you compute these values, create a session key, computed but not sent directly. It is computed and an encrypted pass is created. Here, a second nonce is involved, XOR with the first one. So again, the timeliness and liveliness is met. Server keeps it. Here, it computes a session key and only holds it in memory. It does not store it, or it does not. It was not transmitted as well. But when it comes to resource phase, two things are important. One, for the server to verify that the authentication context is met. Secondly, the variance of attributes. So here again, here the key now would be computed, the symmetry key would be computed, the key is computed on including the session key as well. And a message payload, which includes the attributes, a timestamp, and a session key is encrypted. Embedded into the JWs with all the standard claims, send it to the server. Here the server, like as we said earlier, one, the claims from the JWT can be compared to quickly reject or accept. The public key can be verified to reject or accept. If and subsequently the session key, if the authentication context is met and not valid or rejected, if not reject. Now continue to decrypt and look for the variance first. If variance is again beyond a scale or beyond the threshold, challenge the user or reject the request. If not, only if not and within acceptable variance, does the server allow for access to the resource. So traditional systems, what they do is, if the authentication context is valid, it would allow entry. Not so here. So the with the introduction of the nonce, the JWT and the signers, so what we have seen that there's the impersonation attacks, replay, modification, non-repudiation, because it is signed by the client with its own private key. The password is not getting or credentials are not being sent as is, and data integrity as well, because if an attacker were to even capture the JWT, to modify it, they will have to resign it, which would vary its signature, the signer, and this can be detected. Yeah, so a formal analysis has been done using Skyther, and it passes the claims, aliveness, where we agree, NISync, everything, etc. So to conclude, yes, we have a lightweight algorithm, authentication modality that can integrate into an adaptive authentication system. It utilizes a signed JWT for data transport to ensure the authenticity and integrity of the data. And at each request, multiple checks is now possible to detect attackers and reject at any point at any of these various phases. So even if one level has been compromised, there it is possible to verify at multiple levels now with multiple checks, and it can the system can reject the request either for login or for access. So these are some of the references we described and used. Yeah. So thank you.
Thank you very much.
Thank you.
Thank you, Mr. Vivin.